Hello everyone, we are Group 25 and today we'll present our project titled Diabetic Retinopathy Detection using CNN, completed for the Neural Nets and Deep Learning course. This work is also being presented as part of the Machine Learning Student Symposium 2025. These are our contents. Diabetic retinopathy or DR is a diabetes complication that affects the eyes. Diagnosing it traditionally requires manual inspection by specialist, which is both time consuming and expensive. Delays in diagnosis can lead to an irreversible vision loss. Our goal was to develop an automated deep learning based system that classifies DR severity levels using fundus images, helping speed up and scale early detection affordably. To put it simply, diabetic retinopathy occurs when high blood sugar damages the blood vessels in the retina. Healthy eyes have normal vessels, while DR affected eyes vessels leak fluid and undergo abnormal changes. DR progresses in stages from no DR to mild, moderate, severe, and finally proliferative DR. Our model's task was to detect and classify these stages accurately. We used the 2025 Kaggle diabetic retinopathy dataset, which includes high-resolution retinal fundus images categorized into 5 severity classes from 0 to 4. We pre-processed the images by cropping and resizing to a standard 2224 by 224 resolution, noise reduction techniques like removing black images and applying clay for contrast, and data augmentation through images rotation and mirroring to tackle class imbalance and improve generalization. Our model training used 80% of the dataset, reserved 20% for validation. We normalized images using ImageNet's mean and standard deviation values. We chose the ADAM optimizer with learning rate of 1 to the power minus 5 reduced to 1 to the power minus 6 during fine tuning. The learning rate decreased every 5 blocks to ensure better convergence. The primary metrics we tracked were accuracy and loss, with the final model achieving high classification performance. So this is our accuracy and loss. Accuracy is 96% with a loss of 10%. We can see the graph right present here. Our architecture was based on ResNet 152 as deep convolutional network, highly effective for image classification. Key features for our final model include training for 100 epochs, use of negative log likelihood values suitable for multi-class classification, a modified full connected layer to classify images into 5 DR stages, and additional steps like random horizontal flip and learning rate scheduling with StepLR. We started with a simpler baseline using a fixed learning rate and minimal augmentation and gradually built toward this more robust and final model. A baseline model had the accuracy of 91%, whereas we are getting an accuracy of 96% now. Our team brought an experience from past projects. Rutuja Rashankar worked on multiple CNN models and focused on pre-processing and model optimization. Shravani Latto applied deep learning in healthcare image analysis and has worked on dual input CNNs to enhance model performance. Shravani Gulhane built an emotion detection CNN dealing with feature extraction and model training skills transferable to DR detection. This combined background allowed us to efficiently tackle challenges in medical image classification. These are our references that we referred. Thank you for your attention.